Thank you, Alan, again for that great introduction. It always makes me turn red. But yes, you know, it's kind of interesting. I do bump into a lot of my students over the years, and I was at Monash University for 25 years. So this is my hometown, so we're doing this, this tour around Australia, and I always love coming back to Melbourne. It's a great city. I'm going to talk about safe system approach and positive protection in work zones. This is an accumulation of about 30 years of work that I've done. I have many other areas that I've looked at, but this one I take pride in that it was from this town that we got the safe system into the United Nations, into the Decade of Action. Eric Howard, who is the head of road safety at Vic Roads, was the person who we kept prompting and tapping on the shoulder and saying, Eric, get this in. As you can see there at the bottom, well, you can't actually see it, it's too small a writing, but Pillar 2 is of the Decade of Action for reducing the millions of lives that we're losing, the casualties on roads around the world. Pillar 2 looks at safer roads and mobility. And we were able to support that Decade of Action and push it into places like the World Health Organization. The safe system approach underpins their strategy for road safety. There's the diagram that Eric put up to that document. And so that's in their speed management manual. Similarly to the International Road Transport Forum, there is the diagram again. As you can see, we'll talk about that in a little while. So this is the genesis place of the safe system. So you should take pride in that. And Victoria certainly has a good track record. Let's talk about just all road fatalities, just the scale of the problem. This is an exercise I did a number of years ago where I decided I'd sum up all of the road fatalities since 1925 and then looked at all of the fatalities where people have died in wars and disasters. And since 1925, you can see 34,000 troops had passed away as a result of action overseas. If we look at our natural and man-made disasters, this is the Victoria bushfires, Cyclone Tracy, Bali bombing, Black Friday. Victoria has certainly had its share of that. No two ways about that. The Granville train crash. When you sum them up, it's about 1,200. So when you put that into perspective, the road fatalities, what goes on in our roads and the casualties, and think about the serious injuries, which is 10 times this number, then you start to get the scale of the problem. But Victoria actually does a great job. You've got a fantastic Commissioner of Police who's very passionate. Ken Lay is, I've spent a couple of weeks with him in Kuwait, together with Soames Jobe, who is the head of road safety at Roads and Transport Authority. He's a very caring man and quite sensitive and really is into road safety. And here it is, Victoria at 5. Less than the Australian average. We're still above best practice, but it is without a doubt the best performing state because of what goes on in this state, because it is so progressive in terms of caring about the lives of people on the roads. So other countries, though, are performing better. United Kingdom, right? Where a lot of our original settlers came from. And Sweden, of course. You've all heard about Sweden. Klaus Tingvall, who was the head of MUARC, Monash University Accident Research Centre at Monash. So how did it come about? Well, it evolved roughly in the mid-1990s when Sweden and the Netherlands, their sustainable safety, Netherlands and Sweden with its Vision Zero, came in and started talking about this is what we need to do for road safety. Its application relied on road authorities and others interpreting the principles and planning actions consistent with this thinking. We called for a paradigm shift. I used to have a lot to do with shock jocks and the newspapers here and on John Fane program. I've done it all. And we were talking about this shift in thinking. for road safety. So development of a management of a road traffic transport system that is inherently safe for the human being, right? You don't expect to die when you travel home tonight. That's what we want. A human error tolerant transport system. So it recognises that you might make an error. In other words, you've been working all day really hard. Maybe you didn't get enough sleep last night and you suddenly close your eyes and have a micro sleep. You shouldn't die because of that, even if you've made that mistake and you have a crash. A system must be actively or passively aware of the human error and compensate for it. To err is human. We've heard of that. That's a part of our nature. We do make mistakes. That's how I've learnt over the past 30 years, is through various mistakes that I've made, and I've looked at it and a few little experimental glitches and then suddenly observed something. Human factors contribute to 90 to 95% of fatal crashes, as Evans told us in a book 30 odd years ago. In terms of deduction, we try to change the human problem. We try to change human behaviour. We try to make people obey by the laws. But some humans don't want to be trained. The 5 percentiles, right, that are out there. I'm not going to go by the speed limit. No, shove your speed limit. I'll do it my way. Sometimes they don't want to be so compliant. And we've heard about some of that today. So it's important to recognise humans make errors, assess the consequence of those errors, propose countermeasures that reduce crash severity to survivable limits. That's what we're talking about here, survivable limits. Eliminate or compensate for the human error and shift the responsibility from the road user, the nut behind the wheel. Stop talking about that and just say, okay, we've got to take the responsibility back onto the road and system managers. We've got to do something to make sure that that we prevent them causing injury. And I use the example of my son. I have triplet boys, so you can imagine my dilemma when they turned 18 and wanted to drive. So one of them was particularly recalcitrant. He kept on breaking the law. He kept on speeding. So he lost his licence. And then he goes and uses his brother's licence, which looks just like him. They're identical. Gets caught twice. The second time round, the judge looked over and says, "Sunshine, next time you're going to go to jail if I catch you again driving without a licence." And so I then spoke with Soames Job, who's a psychologist, and I said, "Soames, I've got a problem." And I'm not the only road safety expert that has these sorts of problems. You hear these stories, I chat with others. I'm not going to name them, I'm not going to tell you who, but they had similar problems. And so he said, just sit down, talk with him, just communicate with him. And that's the issue here. Communication is critical in everything we do. It's really important to talk things out. And so we sat down with him and said, what, we're going to visit you in jail now? Is that where we're going with all of this? Is that what you're doing? You're not complying with the speed laws? And he learned his lesson. And he spent a year not driving, begging and borrowing from his brothers to give him lifts. I was giving him taxi fares. We were taking him around. But the system, the key here is the system caught him out. The system was the regulatory system, the fact that he got hauled in front of court, the fact that he's been caught out doing this, and that helped save his life. And I thank the system for that. So the safe system is not just the hardware, it's also the environment, the management, the regulations that are all in there. And it should be set up in such a way that it is empathetic towards the road user, to help them comply with the law. That's the Swedish way, actually. Help drivers comply with the law. No more trading off lives for benefit of mobility and cost efficiency, a more humanistic, ethical approach. That was it. So we were jumping up and down, talking about Vision Zero. When Klaus came to Australia, he was talking about zero deaths. But we had Soames Job a decade earlier where he said in one of his papers, many fatalities occur not because of the driver error, but because of driver error combined with a negligent designed road system and a politically acceptable but technically substandard vehicle. Most of us would not condone a legal system which handed out a death penalty or permanent disability for crimes, such as the misjudging of the camber of the road or driving when slightly drowsy. So we should not accept a politically determined traffic system which meters out such penalties. He said that a decade before Klaus came. Here's the chart, again, the league table, international league table, where you've got annual deaths per 100,000 population. That's your risk as an Australian in the Australian road environment. So, in the USA, look at the USA, they're at 10.7 deaths per 100,000 population. Here's Australia, just a little bit below the median. We are slipping back a bit, but Victoria's keeping us more to the left than to the right. It's the other states that have got some problems. And here's Europe, down here, at less than 3. Now, all of our road design guides are based on AASHTO. US codes, right? US standards. That's what we look to, because we're a vehicle-based society. We've got roads everywhere. That's the template that we used over the past 30 to 40 years, or maybe almost century. However, Europe is at best practice less than 3. And in particular, we can look at the United Kingdom and Sweden for those tips of what is best practice. And that's where we should be thinking about, and we have been. We've been looking towards it. My one ambition, before I cark it, as we say, is to get trucks to keep to the left side of the freeway, like they do in the UK. That would be wonderful. And they can only pass if there's a second lane. If there are 3 lanes, they're not allowed in that right lane at all. So those of you that have some influence, push that one for me, would you please? Because mixing trucks with cars is lethal. It's huge kinetic energy, and I'll show you something about that shortly. So here's 60 km/h work zones. These are unacceptable. This is 70. Any vehicle that loses it through there, someone falling asleep, would take these people out. So we were talking about these sorts of sites. We're talking about how poor protection at work sites, how you're getting poor roof strengths for rollover crashworthiness, roadside poles and trees in 80 km/h zones, which are not survivable if you hit them. If we spoke about incompatibility between the trams and buses and pedestrians in this city. That's all changed too. You notice the trams? Notice how they've got wonderful shrouding? Notice also where you stand at the tram stop, the bollards at the front end. That's our work. We've been pushing that. Rather than having that ramp, which has killed a few people because a car rides up that ramp. It's what Alan was talking about, the ramp. The car falls over. Who was it, the head of the Australian Football League? That's how he died, in his car. He went up the ramp, went over, crushed, and died. I've forgotten his name. Yeah, someone said it. No. Hamilton. It was Hamilton. That's how he died. Concepts of Vision Zero, introduced by Tingvall in 1998, was a breath of fresh air for us. We were rejoicing, and in fact, I'm a disciple of Klaus. He hates me saying this, but both George Recknitzer and myself, George lives in Melbourne and still active. He doesn't like us saying that, but we are his disciples, without any doubt. Community and political pushback. Everyone pushed back. When Eric Howard started selling this, and others, there was enormous pushback. What, you crazy? That's going to cost us a fortune. It'll be too much. We can't go that far. How is that going to work? And I can tell you, it was coming from the engineers. It's the engineers that we've got an issue. And right at this moment, Ian Cameron, who is chair of the Austroads board, is trying to influence the engineers. We're trying to influence them. I'm one of a couple of engineers in this country that are pushing this. But let's have a look. Some of you may have already seen this video, but I'll play it for you so that you can see how this is relevant. So this says, how many people are killed on America's roads?
I don't know, probably more than 20,000, I would assume.
100,000.
I'm going to say a lot, so probably around, say like 1 million.
400.
Can you hear?
75,000?
50,000.
I want to say a couple 100,000.
About 1,000.
Millions.
Can you hear that down the back?
100?
I don't have an idea, but I think it's a lot of people.
Probably about 400,000.
Probably 200,000?
Golly, I think it's maybe around 35,000 these days, something like that.
What are the leading causes
Drunk
of car
driving or
crashes?
Impaired driving.
Texting and driving.
Inattention.
Distractions.
Alcohol.
Alcohol. Alcohol related for sure.
I'd say not paying attention to other people on the road.
For driving, driving test.
People are irresponsible in driving. They don't pay attention. They have distractions from like cell phones, putting makeup on, to just eating. See, I'm a full-time pedestrian, so because I'm legally blind, so I've almost got hit several times just in the crosswalk because people are not paying attention when they turn right.
Speeding, no seatbelts, things like that.
I've heard drunken driving and then fatigue are the two big ones, perhaps.
This guy's on the money. Will we ever see a day when there are no fatalities? So there's 32,000 fatalities in
not
the
gonna
US each year.
No, not at all. I don't think it's realistic. But I do think that if we work towards reaching that goal, that we will decrease the amount of fatalities.
Absolutely not. This is humanity.
No.
No, not with as many cars and not with, the amount of people here.
Yeah, if people stop using their phones while they're driving.
It's not incredibly likely, but it's always good to strive for perfection.
What is a good goal for our state? That's California. This is where the interviews were
If we
carried
can
out.
get it under 1,000, that would be cool.
I would say we could at least cut it in half of what it is now.
I have no idea. 2.
If the number was down to 10, I think that'd be good.
Acceptable would be anything lower than what it is now.
Say maybe 1,000.
I think our goal for fatalities needs to be brought down at least 50% in the next couple of years.
10.
Under 5,000.
Like under 100.
Less than we have now, I suppose.
What is a good goal for your family?
0?
0.
Well, you'd have to say 0 for that.
For my family, personally, 0. That's acceptable for my family.
0. None.
0.
0.
0.
0.
None.
0.
0.
None.
Oh, obviously we'd hope for 0. Yeah.
0.
0. You
Yeah.
leave the house, you come back to it at the end of the day, I feel like.
Should the goal be 0 for everyone?
Yes. Sure. Yeah. That'd be great.
Yes.
It should be, yes.
Yes. Yep.
Yes, definitely.
Yes. I think there should be 0.
I mean, yeah, you have to aim high, I would say.
It should be 0.
That should definitely be the goal. I absolutely agree, yes. That should be the goal, 0 fatalities.
And that's what we did to convince the Americans to go for 0. There's a lot of Australians that go over, usually in the winter, to the Transport Research Board Academy of Sciences conference, and we keep impressing upon them because we know that's the source of a lot of our standards, a lot of the information that comes, and the parent companies, etc. We know that comes back to Australia, and so if we can influence them there, then we'll get some benefits here. And so the heads of the various research centres, CARS Q, MUARC, CASAR in Adelaide, ourselves at TARS at UNSW, the George, Rebecca Ivers, we all do that. And so the TAC have actually made a similar video here, which they showed last week. They launched it last week. So if you can get a hold of it, use it to convince others, okay, that yes, 0 is the aim. Okay, so how did the safe system approach come about? Let's go back to that. So when Klaus and Narelle Howarth and Klaus Tingvall had pushback on this from the engineers, what happened is they said, well, okay, well, how about we do it this way? If you haven't got the money to put the system in, reduce the speed, reduce the kinetic energy. So where there's conflicts between pedestrians and cars, make it 30 kilometres per hour. With possible side impacts between cars intersections, 50 kilometres per hour. Roads with possible frontal impacts between cars, 70 kilometres per hour. That's your rural roads, right? Where everyone wants to drive at 100 clicks. When I go down to Balnarring to visit my mother, it's still 100 clicks along that Balnarring road. It should be 80. Roads with no possibility of side impact or frontal impact, that's your freeway, your Hume Highway, 100 clicks, and the other highways. So let's have a look at Ian Johnson. Let's remind ourselves once again what Ian told us about small differences in speed and what they can make. I'm sure you've all seen this ad, but let's just play it again.
What you're about to see will change your mind about speeding. Two identical cars, one travelling at 60, the other at 65. A sudden change in the road ahead, and both drivers first react, and then, a moment later, they brake. And things start to get interesting. Down here, the difference is extraordinary. In the last 5 metres of braking, you wipe off half your speed. So this car is still doing 32 k's when it hits. This one also hits, but only at 5 k's. So no matter how good a driver you are, 5 k's difference up there makes 27 k's difference down here.
That's amazing, isn't it? Australians are pretty good. That's the Matrix crew who did that. It's quite good, very powerful. And we're hoping it is influencing a lot of people in Australia to, you know, just keep it down. That's why there's such an intensive camera program in Victoria, why you've got a threshold of 3 kilometres per hour on your speed cameras. Because it makes a difference. If the average speed of all of the vehicles on a particular stretch of road, for every kilometre that goes up in average speed, you're getting somewhere in the order of about a 20% increase in fatalities. It's stunning. We see it. Okay, so we published a bunch of papers and we got quite vocal. We published opinion pieces back there at the turn of the century. And I had Peter Daly, Chief Engineer from the Royal Automobile Club, come up to me and says, I'm going to sue you for defamation. I'm going to sue you and George for destroying the reputations of engineers who have been working hard to design roads. And I said, you little beauty, thanks Peter, let's go. Let's go to court and I'll get all of my media colleagues. They can all come along and we'll see who come out best with this one. And then what happened was Klaus Tingvall, who had returned to Sweden to take up his post as head of the National Road Authority, Swedish National Road Authority, came back with an idea and started talking to Ken Ogden from the RACV and to Peter Daly and to the AAA, the Australian Automobile Association, about a new system they introduced in Europe called European Road Assessment Program, EuroRAP. They said, you guys should do that here in Australia. And Peter Daly took up the challenge and together with a number of others put together the Australian Road Assessment Program, which is helping save lives. So we flipped it, flipped the argument. So it's all about communication, listening, trying to change things, having that influence. You've heard about the story, The Power of One. Well, that's what we're talking about. If you've got something that you can change to make it safer for somebody, do it. Don't hold back. So here's what Eric put together. The safe system model. It's a biomechanics criterion instead of cost benefit. The central piece is the human tolerance to physical force, and so we adjust our speeds and make sure our vehicles are safe and the roads are safer so that people survive in a crash. It's all about the human tolerance to injury. So a biomechanics criterion, essentially. So if I was to do this, hopefully that'll work, it'd probably kill me. So I know what my tolerance level is. About 20 kilometres per hour into something solid, isn't it? Those that are younger, the younger ones of you, it would be a lot less, a lot higher speed rather. So you would have a greater tolerance. But there are limits, aren't there? We keep saying that to motorcyclists, don't we? You have your limits in injury tolerance, and to pedestrians and to cyclists. But here are the graphs. This is the fatality risk percentage versus impact collision speed. And so you can see here the pedestrian curve for a pedestrian or cyclist. You can see here in a side impact what that risk is, and likewise here for frontal or hard objects. And you notice that it rises, it suddenly rises once you get above a particular collision speed. So for pedestrians it's about 30 kilometres per hour, it starts to rapidly rise. What we like to do is put a line at about 10% fatality risk. That gives us a very good return. And so we tend to design, we want to design for these sorts of speeds. And that's where Narelle's and Klaus's rebuttal came from. If you haven't got the money to put the infrastructure down, then reduce the speeds to 30 for pedestrian zones, for where you've got intersections, get them down to 50. That's why we have roundabouts, right? It's a controlled intersection for speed. So you, in cars, instead of hitting perpendicular, the maximum survivable speed in a car that T-bones another car, if you're in a Merc or a Volvo or something that, or even our 5-star cars here, the Fords and the Holdens, it's about 25 to 30 kilometres per hour is your survivable speed. Beyond that, you get serious thorax injuries, serious head injuries. So it's about 50. The reason it's 50 is because you've got what's called a momentum exchange, delta V. So a car that hits you at 50, your car will experience 25 kilometres per hour increase in change in velocity. And with the frontal impact, it's about 70. The cars are only designed, 5-star cars are designed to about that speed. In other words, to hit something, which is another car, if you hit another car at about 65, 70 kilometres per hour, you should be expected to be able to walk away from the car. You'll be shocked, you'll have bruises from the seat belts on your arms and that, but you should be able to walk away from it. That's what they're designed to. The Princess Diana fatality, think of that one. That was in the safest car, a Mercedes, right? She wasn't wearing a seat belt. Fiat wasn't wearing a seat belt. He was drunk. The bodyguard had the seat belt on. Rhys Jones, supremely fit individual, was laid up in hospital for a couple of months. His tongue got ripped out from the deceleration. The speed of impact in the safest car in the world was about 85 to 90 kilometres per hour into a pole. Absolute limits of survivability. So when you hear these stories about people saying, oh, he had a crash at about 120 kilometres per hour and he survived, well, probably didn't hit anything hard. It's what you hit is the issue here and how quickly you decelerate. So here's 30 kilometres per hour. If we don't have appropriate enforcement for our 5% of people who speed and just flaunt the law, they can go anywhere up to about 15 kilometres per hour higher, and so your risk rises to about 60%. So down here, it should be at 30. Let's look at work zones. Work zones, we've set them roughly at about 30%. But if you don't have the enforcement, and that's the issue here, then you start to rise very rapidly because you're on that steep part of the slope. So you're up around 90% when people blow that limit at about 15 k's up. That's why enforcement is critical. And I would suggest what we need at every work zone, and you're a state which can do this because you have got a commissioner and you have got politicians here that are tuned in to a safer system. They are tuned in. And you've managed to introduce new things into this state continuously to get your fatalities down. And I would suggest you introduce point-to-point cameras at any work zones. The cops install the cameras at either end. They take care of the fines, etc. Or it can be done through contractors. You've already got that through. You've got contractors collecting fines. And every speed zone has a point-to-point camera, and people know if I go through there, just like you go through the Domain Tunnel, no one speeds through there. You know you're going to get booked, so you don't speed. It's human nature. And that's what you're trying to do, is change human nature. If you're trying to do it through education, you're trying to do it through telling people not to speed. If I know I'm going to get booked, I'm not going to speed. So here's 50 kilometres per hour. When we reduced it from 60 to 50 those decades ago, when we got that bit of legislation through, that was wonderful. And that was the College of Road Safety, because we had people from the various road safety centres, regulators on the committee. And when that got pushed through, it was a wonderful day for pedestrians, because we reduced it by about 2/3 our fatalities for peds and cyclists and vulnerable road users. That was a great piece of legislation. got sound? We haven't got sound. No sound. Okay, I'm not sure if you've seen this ad. It's a TAC ad, and it's effectively about how a person, what they suffer when they get struck by a car. And what the surgeon's saying is, first of all, when the car hits you at 70 kilometres per hour, you get rotated around, your head strikes the windshield, you get fractures in the skull, your brain turns to pulp, and then you get thrown forward. And if you haven't been killed in that impact, then you land onto the roadway, probably with more severe injuries, some more injuries that are imparted on you. It's not it's on the bare limits of survivability, and if you do survive, you'll probably be a vegetable for the rest of your life. Here's a crash reconstruction I did some years ago into a pedestrian, and it highlights why we choose the speed limits, why Europe is choosing the speed limits that it chooses for pedestrian-intensive areas. This is a crash into a pedestrian who was challenged, intellectually challenged. So when he walked across the road, he was walking like that and got struck. You can see the skid marks here. Now this chappie had had a beer. He was 0.03, the driver. There's where the head struck in the vehicle, on the windshield. Fortunately, the windshield, not the A-pillar. So he survived, this pedestrian. This is where he was crossing. Notice the skid mark, the left skid mark. So the brakes were applied earlier. Notice this street light here. There's a street light here. Not much else. We've got to talk about perception reaction time. This is what it's all about. So when you drink alcohol or you're tired, when the bikies smoke a bit of pot and they go up into the dandenongs, yes, they do that. They're numbing their brain. Think of it, you're numbing your brain. If you ride a motorbike, why would you numb your brain? It is the most incredible skill that you possess to ride a motorbike. You need exceptional skills, way more than what a normal car driver does when you ride a motorbike, because your error tolerance is so low. So don't numb your brain with alcohol. Because you reduce your perception reaction time, and that's what this is all about. So from about 1 second up to 2.5 seconds. So Mark Webber and I have something in common. We roughly have the same perception reaction time, except he knows how to handle the cues in order to drive a Formula One racetrack like round here. I couldn't do that. But we have the same perception reaction time roughly. So it's about 1.5 seconds. Each of you have similar perception reaction time. It's a human characteristic. To detect the presence of the pedestrian, identify that the pedestrian represents a hazard, decide the action to be taken, react or respond by taking the action, in other words, apply your brakes. This is the Holy Grail equation. This is equivalent to Einstein's E = mc squared, except we're on planet Earth. It's Newtonian laws, it's Newton's laws, and that's what's been governing whatever we do here forever. It's the velocity squared equals 2 times acceleration or deceleration times the length of a skid for a car if it's a car. So there's your perception reaction time. So the car travels a distance by the time the brakes are applied, and then when the brakes are applied, that's the skid distance. So you've got to add the two together. Now what we can do is we can equate this to falling off a building. It's the same equation, it's the same Newtonian law, except instead of A being the deceleration of the vehicle through braking, we have G, gravity acting, 9.81 metres per second. And the distance over which that acceleration acts is the height. So we can equate kilometres per hour of impact to driving off the top of a building or jumping out a window. So for example, in a car, at 60 kilometres per hour, driving off a 3-storey building, it's equivalent to that. At 80, it's like driving off a 6-storey building. At 100, it's a 10-storey building. At 120, that everyone's been pushing that we are allowed to drive at, or 130 on the Hume Highway, we're hearing that all the time. Well, folks, that's what you're doing off a 20-storey building. So you better have the system right. You better have all those barriers put in place. That's what the Germans do. The Germans have a proper system. They have a good road system. And I hear all this pushback on driver training. come on guys, we've shown driver training post-licensure does not really work. I'm hearing 146 million if Labor gets dropped into driver training. Well, here's my official statement, it's garbage. It won't help. Stick the 146 million into fixing roads. I'd prefer to see that. Driver training, yes, will give you some benefit, but it's minimal, and many people have shown it. Many very learned experts have shown it. So impact is not survivable over 80 kilometres per hour. Here we go. So this is a crash lab. This is a 60 kilometre per hour impact. Notice you can't stop yourself from hitting the steering wheel. That's why we have airbags. He's wearing a seatbelt, that dummy, crash test dummy. Here's at 100 kilometres per hour with the boot fully loaded. There you go. That's the difference in kinetic energy. It's the same vehicle type. That's why you see Anders Lie from the Swedish National Road Authority showing these pictures. That's what we're doing every day when we cross the road, right? Being hit at 30 is equivalent to 30 kilometres per hour. It's like jumping off the roof of a house. 40, it's jumping out the window of a two-storey building. 50, it's jumping out the window of a three-storey building. At 60 kilometres per hour, it's jumping off the roof of a three-storey building. Now think about that when you cross the road the next time. The other thing that people shouldn't do is cross the road when there's a red light. The reason is when you cross the road and it's proven that you crossed it when you weren't supposed to under law, in this state it's okay because we've got TAC no fault claim, which is wonderful. I really support that. In New South Wales and South Australia, they don't. You have to go to court and sue to get your money to help you survive your incident. So there is what's called responsibility that's attributed to you for having crossed the road when the light is red. Okay, at 36 metres, this is this intersection I was talking about where we did the crash reconstruction. At 36 metres away from the pedestrian crossing with a low beam. Can't see the ped. Can you see the ped there now? This is high beam. There's the ped. Now I'm getting closer to the intersection. At 20 metres away, I can just make out the trousers because the trousers are light. That's why what Alan is telling us about this light, this pedestrian light, wonderful. Got to get them out there. Give them to the kids. Just give them away free. Get people to wear them. Here's at 14 metres, just starting to see the trousers. I can't see his head, just a bit of the face. It's all about contrast. Okay, so is it possible to brake in time, assuming 1.5 seconds at 50 kilometres per hour? Cars travelling 14 metres per second, 1.5 seconds travels 21 metres. Not possible to perceive and react in time. It's just not possible. So you hit the person at 50 kilometres per hour. At 40 kilometres per hour, 1.5 seconds perception and reaction time, you're travelling around 11 metres per second, 1.5 seconds, you travel about 17 metres. Car will brake for 3 metres, needs 10 metres to stop, so you'll hit the ped at 33 kilometres per hour. It's like jumping off the house or your roof. If you've got a sharper perception and reaction time, and that's what this chappie did with his 0.03 alcohol content, he did it in a shorter time. Hits at 17 kilometres per hour. So he was good. 30 kilometres per hour. Car travelling 8.3 metres per second, 1.5 seconds travels about 12.5 metres, car needs 6 metres to stop. Whoops. No impact. That's why Europe has gone to 30 in pedestrian intensive areas. You hear about it all the time. You say, oh, goodness, 30, why not just not drive at all? But no, we're not suggesting that. We're suggesting that where there are a lot of pedestrians, where there are children playing, near schools, etc., this is the speed that Europe has adopted. Now, it's up to us what we do, but 40 kilometres per hour in the school zones has been good. Has been excellent. That's shown to improve. So key points from this is overhead lighting is critical. What Alan's talking about in terms of that lunar lighting, get your sights lit up. Make sure that happens, because then someone can see what's coming, what's going on. Most drivers will ignore the speed limit and drive at least 10 to 15 kilometres over the set speed limit unless enforcement is present. Now in Victoria that may be not quite that much because you've got a pretty strict enforcement regime here. But in New South Wales, I can tell you, they do blow it at those speeds. They don't abide. A worker struck at 40 kilometres per hour limit will have a likelihood of about 30%. At 50, it's about 75. Positive protection safety barrier with a reduced speed limit and strong enforcement was shown, and also with tactile line marking. Works. That definitely works. Now let's have a look at fatigue. Hopefully the sound. Yes.
One more time. From the studios of 7 Perth, Susanna Carr and Rick Arden.
Good evening. You're about to witness an amazing near miss on a West Australian highway. The video shows a fatigued driver straying into the path of an oncoming road train travelling at more than 100 kilometres an hour. Police say it's a wake-up call for all drivers. David Cooper reports.
Watch the white van. The driver is about to come within millimetres of death. It was filmed on an outback highway somewhere between Karratha and Panawanika.
Guys, we had a rollover back here, turn around.
By a camera mounted on a truckie's dashboard. Watch again. The van drifts across to the wrong side of the highway, straight into an oncoming road train. A truck driver forced off the bitumen in his attempts to avoid tragedy. The van driver was part of a mining company convoy. The company, HWE Mining, says he was fatigued and the video is now being used in safety briefings. Thankfully, no one was killed or seriously injured.
He's just...
Have a look where he goes. When it really goes bad, it really goes bad. He goes into a culvert, an unprotected culvert.
Amazing. It's amazing that
so you've got it accentuated
Senior Sergeant
again,
Ian Clark is one of WA's top traffic law enforcers.
A collision between a van of that size would mean instant death for the driver of the van. It could have been a terrible disaster.
Ian Clark says fatigue is one of the biggest risk factors for drivers, particularly on outback roads and highways.
So it's reasoned Swiss cheese. When all the holes line up, it happens. So you've got to really be careful, and that's why we're putting in wire rope barriers everywhere. That's why the TAC has invested in this, and Vic Roads are installing all of the cable barriers around. In the motorcycle areas where all the motorcycles go, Great Ocean Road and up into the back blocks, we've shown that W-beam combined with the rub rail is very good. That works. And that's where that should be installed. Okay, so those of you that are motorcyclists, I know we've already done the tour, we've had a few pushbacks. But there are reports, and you can look at those reports. They're on our website. I've got about a dozen papers. It's a red herring. Don't listen to what the motorcyclists are saying about cable barriers. It's just wrong. Sweden has installed their 2+1 systems. They've had about a 60% reduction in motorcycle fatalities. And that's because these cable barriers stop other vehicles coming across, taking out the motorcyclists. And we heard Bill Bowie last week talk about the installation of cable barriers, of wire rope barriers here, where the motorcyclists have kept away from the barrier, which is great, so keep them away from that median, and also they've dropped their speeds. So it's working. So these are other issues. This is at 100 kilometres per hour, 25 degrees impact angle. And you'll see here a four-wheel drive. Right? And then you're relying on the crashworthiness of your vehicle. This were tests that I did with Klaus Tingvall and Swedish Road Authority quite some years ago. It's 2000, right? So it's old. But this is at 80 kilometres per hour, 45 degrees into a concrete barrier. Okay, they're just not survivable crashes. This doesn't happen that often. And in fact, it's quite rare. But when it does happen, it's bad. And that's why we're going to flexible systems. That's why we're going to the cable barrier systems. If you think it doesn't happen, have a look here. This is a bit old. It's up near the, I've forgotten which bridge that is. One is Sir John Monash's bridge. It's on the Monash Freeway. But have a look. If you think that people don't hit them, yes, they do. So keep those speeds to about 60 clicks coming off the ramps. Don't make them higher because it can be quite lethal. Here's concrete F-shape that's everywhere, okay, that have been installed because we copied the US, right? the intention is 100 at 25. So that's a sharp angle. Most cars don't hit them at 25. They hit them at much lower. What we're seeing from the research, a lot of the naturalistic driver study and other research coming out of the US and here, they're hitting them at about 10 degrees to 15 degrees. So it's not as severe. But the intention of this type of profile is meant that the vehicle rides up and then rides down and it sheds some of the energy. The problem is you see rollovers all the time happening. I've seen it many times here. So we've just got to be a bit smarter with our barriers. But if you don't think that that's happening, have a look at this. Again, Monash Freeway down past, close to Toorak Road. Look at the wheel. They get up there and you've got to make sure these are frangible because they hit them. So that's why we love wire rope barriers for vehicles if you've got the room. You've got to have the room, but there's been quite a few tests done at Crash Lab where they've had two cars coming in at each other with no room for the working width. We call that the working width, how much it flexes out. So some barriers do work, some don't. So you've got to be careful what systems you install. They've got to be compliant with MASH or NCHRP 350 or the European code. They've actually got to redirect. You can't have systems which don't redirect. This is a system that I developed. I got involved in the design for a temporary barrier system. It was never installed with its guardrail at the front, but you can see that's the working width. We talk about a working width. So you've got to make sure your workers are not in that zone. They're not anywhere in this area here where this barrier can deflect and hit them. So you've got to be careful of these systems in that regard. But what's going on here? What do you reckon? I think these guys are in trouble. This is what's happening here in Queensland. Working width? Nah. What happens when you hit these at 100 kilometres per hour? So any safety barrier system, temporary or permanent, needs to meet MASH, needs to meet the NCHRP 350 or European code. And they are set down. You can see them, the tests that are required. You need to make sure that they're compliant. And there's also a set of other parameters that they must meet, the temporary barriers. Test deflection is really important so that you know what that deflection is. Temporary barricades and channelizers. These are the ones that aren't barriers but just direct traffic, direct pedestrians. They need to be hit too, because it's really important that when someone hits one of these barricades, an errant vehicle, that it doesn't injure the occupants of the vehicle. This is a failed test. This was meant to redirect, but it didn't. But it shows you what it should do for a channelizer. So we have these systems where we hit them at 100 kilometres per hour and figure out, okay, will they injure somebody? Will they hurt someone in the vehicle? So they shouldn't affect someone here. This was carried out
the state government is being urged to adopt a new type of road sign support, which could save lives. The aluminium honeycomb posts crumple on impact, protecting the driver and passengers.
Travelling at 70 k's an hour, this sedan heads straight for the signpost. The vehicle snaps the post off at the ground, the aluminium frame wraps around the front of the car and it stops 30 metres down the road.
In this vehicle, it's quite likely they could have died as a result of an impact into a solid pole at that speed. At 70 kilometres per hour, certainly they would have had serious brain injury.
Aside from the fractured windscreen, there was no major damage done inside the car. It was the bonnet that took the brunt of the crash. By sticking with the vehicle, the sign is prevented from doing damage to other motorists.
It's not flinging off to one side, falling to one side, hitting pedestrians.
About 40% of deaths on our roads occur when a vehicle crashes into an object on the road's edge. It's hoped the collapsible poles will reduce that figure. The scaffold posts are commonplace in Europe. Queensland, Tasmania and South Australia are testing them, while Victoria and New South Wales are considering their own trials. They cost a little more than traditional steel poles, but their manufacturer says it's worth it.
If you save some lives, it's very cost effective.
Ben Lewis, 10 New.
Okay, and so we have in the new, I've just completed writing about a year ago, part 2 of the barrier standard with Rod Troutbeck. And we have rigid sign support, breakaway support, impact, test procedures, also for energy dissipating. Make sure that they're compliant with those procedures. We've worked with all the regulators to make sure that we've got a consistent test procedure now. So it's all about flexibility, working with all systems must be tested. Don't use an untested system. Conditions in which they're installed need to be as close as possible to the certification test. Even barricades need to be tested to ensure they don't have adverse outcomes. So get your crash cushions in there. And in fact, in Victoria, Victoria was the first state where a project engineer who installed temporary barrier systems was charged with manslaughter because he was the supervisor of a site which had temporary barriers with a blunt end terminal, and a drunk drove through at night when the site was down and wiped himself out and killed himself. And it was a real fright. It put a real fright into the Institution of Engineers. The charge wasn't upheld, so, but there was a lesson learned that, you know, you're responsible even if the person's in error. You need to consider what happens.
Every day, lives are saved with highway safety products designed and manufactured.
So we're
by
talking about
Traffics
truck-mounted attenuators here.
The
This is
Traffics
one
Devices
product
Scorpion truck-mounted
which has
attenuator
been
has saved the lives
sold
of many motorists
and
and
being
highway
used.
construction workers throughout the world. In the UK, Traffics Devices passed all test criteria for the lorry-mounted crash cushions test 3-51.UK. As of April 2009, the Traffics Devices truck-mounted attenuator was the first manufacturer to pass this test. Traffics Devices is the world leader in impact attenuator technology.
Look at this.
A man has died after a crash in Brisbane's southeast. The 24-year-old's car collided with the back of a truck on the Gateway motorway at Carindale just after 9 o'clock last night.
You can see what it is. It's the system,
he was
isn't it?
pronounced dead at the scene.
What happened here?
The
Well, we
wreckage
learned
has now been
when we were in
cleared.
Brisbane a few days ago, they hadn't deployed it properly. And they went out with it undeployed totally. So look at when you're deploying systems, you've got to make sure that you set them up before you expose them to the traffic. I looked at some of the barriers. This is our next challenge. I'm looking at this very closely now, trying to look at, okay, a 44-ton truck doing 100 clicks on a freeway. These are the barriers. And this has happened on the Monash. I've seen it. A few instances where these trucks penetrate. Now we're going to be doubles, be triples, 83 tonnes. So one way to control them is through electronics. We're getting a tsunami of electronics coming over from the States. So maybe it's time to start controlling these things the way we control jumbos and other massive structures that move around amongst us. So these things don't hold them. But I've seen cable barriers. I've seen the level 4. There was one classic one with a bridge beam that came off and wrapped itself around on the Ferntree Gully Road. And there was another truck and it pulled the truck up, the wire rope barrier. So we're exploring that. We've still got more things to explore to see how we can deal with these massive energies. It's huge amounts of energy. So achieving a safe system needs a high level of commitment and coordination, and all credit to AAPA for doing this roadshow. Trying to make things consistent around the work sites. It's really important. Understanding human limitations, and accepting that drivers will exceed the post unless there is strong enforcement. Shared safety responsibility between users and the road managers. And I was to tell you about this new workshop series. And so that's the end of my presentation. Thanks very much.